Okay, guys, we're ready to finish this problem. I know we had a second part there. So let's go ahead and graph these points. So we have -3, 5. We have -1, -3. 0, -4, 1, -3, and back up at 3, 5. So you can see it's a nice parabola. Close there. And then it says indicate the speed and direction. And so to do this, all of your points that you graph, so we graphed one here, and that was at t equals -3. And we graphed a point here at t equals -1, t equals 0, t equals 1, and back at t equals 3. So that, and then we need to add our arrows because this is the direction. You can see that the graph moved. So it went from -3 and the direction of movement that it went. So the speed is actually represented by the different increments of time that we go through. And so you can see where we are at any given time. And then the orientation is represented by the little arrows that show how it's the direction it's going. Okay. And so that's it. That's how you do speed and orientation. It's kind of given by itself there. Again, the speed is represented by the different changes in time and where you are, and then the orientation are the arrows that tell you which direction you're moving along the graph. I'm not going to take time to do the second one there. It's the same type of thing that you would do at the first. Again, the orientation and the speed kind of come with it. All right, the next one, this is a pretty cool problem. I'm going to show you a neat thing to do with Desmos on this one. So this is talking about a projectile. So something you can imagine either coming at you or for us, we're just talking about moving away from a particular point and where it's going, its path. So in the key concept box here, it says for an object launched at an angle theta. And so you can see, here's our theta here. Here's theta. With the horizontal at an initial velocity, v sub 0, so v sub 0 is initial velocity, g is the gravitational constant, t is time, and h is the initial height. So basically where something begins its motion at. So in the problem we have below, we actually have a picture already drawn for us. It says Kaylee is practicing free throws for an upcoming basketball game. She releases the ball with an initial velocity of 24 feet per second. So we need that, 24 feet per second, with an angle of 53 degrees with the horizontal. That means, and you can see in the picture that the horizontal there is the red line. The horizontal distance from the free throw line to the front of the rim is 13 feet. So horizontal distance is 13 feet, and that's this guy right here. The vertical distance from the floor to the rim is 10 feet, so this length. And it says the front of the rim is 2 feet from the backboard. So we've got, that's past the 13 feet that she is from the basketball goal. And the last thing is that she releases the shot at 4.75 feet. So she's kind of a little thing there. That's how high she is. What you want to know, does Kaylee make the basket? And so we're going to use our equations here. We have x equals t times initial velocity times the cosine of theta. And so for that, t is going to be our independent variable. The initial velocity, they gave that in the problem, was 24 feet per second. And theta in the problem is our angle measure, and it's 53 degrees. Okay. So we've got plenty to put in there. We've got x is equal to t times the initial velocity, which is 24, times the cosine of 53 degrees. Okay, so that's our t part of the parametric equation. And then I can get it to move here a little bit. Then for our y, it says is equal to t times the initial velocity times sine theta minus 1/2 g t squared plus the initial height. So again, we're going to need the initial velocity, and we need theta. And then g is the gravitational constant. We're going to, g is 32 feet per second. And h sub 0 is the initial height. Well, she lets it go at 4.75 feet. So I know the gravitational constant seemed like I pulled that out of air, and I kind of did because I Googled it and I looked it up to see what I was going to have to use for that. I don't do physics on a regular basis, but it is 32 feet per second, so that's a value that we'll be using. Okay, and then I'm going to put those in my equation, and we have y equals t times our initial velocity again, sine of theta, which we know theta is 53, minus 1/2 times 32 t squared plus the initial height, which is 4.75. So I can do a little bit here and say y is t times 24 times the sine of 53, and then half of 32 is 16 t squared plus 4.75. Okay, so there's our values. And here's what I want to do. I want to put those two equations into Desmos. And so I'm going to open that up. I'm hoping. So the first thing I'm going to do is type this as a parametric equation. So remember, it's a x equals and a y equals. This is going to sound kind of weird, but what we're going to do is make an ordered pair. So I'm going to get some parentheses here, and I'm going to put the expression that I have for x, which is t. So make sure you type in t times 24 times, actually, I'm going to do it a little bit differently here. I'm just going to use parentheses, times 24 cosine of 35 53 comma, and then I'm going to do for my y coordinate is t times 24 times the sine, we'll back that up, of 53 minus 16 t squared, and then plus 4.75. So it's treating this, and I feel like something went wrong there. Hang on. It should look a little bit different than that. Okay, so t times, let's see if I change this and go over here to functions and cosine. Okay, that's what I'm going to do. I'm going to say, so on my selections, I'm going to back it up just a little bit. For my x coordinate, I'm going to have t times 24 in parentheses, and then I'm going to use my functions and do cosine of 53. And I want to make sure it's in degrees. I think that may be actually my problem. And then I'm going to do the sine of 53 degrees as well. So I'm going to go back to functions and do sine of 53. And so I am using degrees. We want to make sure I go over here to the settings, and then you can see that it's radian selected, and I'm going to hit degrees here, and this is going to change it up. So I'm going to hit projector mode, and we can see it just a little bit better. Okay, the other thing, it's giving me a range for my time. And so think about shooting a basketball. So when it's in our hand, it's going to be 0, right? And then, and this is more than enough, but I'm going to give it 5 seconds in the air before it lands. Okay, so I'm kind of giving an educated guess on shooting the basketball. Okay, now I'm going to look at the graph, and we're trying to decide, is she going to make the basket? So when you can see the path of the ball, and then I'm going to add to that, not something that you necessarily need, but I'm going to put some restrictions on here. I know that the ball needs to go at least 13 feet. That's the front of the rim. So I'm just going to put a little marker there and say x equals 13. And then I'm going to put another one, x equals 15, because I know that the basketball goal is 2 feet deep. And so you can see what that does here. It kind of gives me the goal between the blue and the green line. And then I'm actually going to add one more, because the height of the goal is 10 feet. So it's got to go at least that high, which would be y equals 10. And so basically I have, hopefully you can see that here's where the basketball goal is, up here. The basketball goal is along this little line between the blue and the green. And you can see that she's going to airball this thing. It is not going in. Good try, Kaylee. But it's just not going to work out for you today. So the answer is no, she will not make it.